Okay. Now we're going to mill out these holes. Okay. All right. So these are the operations here. There's either 2D operations or 3D operations. In this case, this is a very 2D operation because we just have holes that we're going down in, and they're not, if they were telescoping holes, they might be a little bit more of a 3D operation. But in this case, they're just a hole from one end to the other, all the same dimension. Okay. So it's more 2D here. We could use something as simple as a boring operation to do that. Typically, that's what we're going to use for an interior, just a hole, a simple hole like this. Okay. And the interesting thing about this is that it will, now notice when I roll over this, it gives you a preview of it. If I go into this, yeah, it all of a sudden goes away. So it's hard for me to point at it. You can see it going around holes as well as going into holes on the side. We're going to do more like the holes on the side. So let's choose bore, and it gives us our setup for that again over here. Our 0.191, okay? I'm just opening up my calculator real quick. So we have, let me go back to Fusion 360. So we need to choose our tool first, okay? First thing that comes up is this. And these, if you are on our account, which you should be if you're setting these things up. In fact, this is going to be hard for you to do if you're not on our Crimson Robotics account. These are automatically loaded for you, and they're in the cloud. It is our Velox library of tools, okay? These are the tools that you can use on our end mill, right? And we have to choose something that is close to 0.191 inches, okay? Now, we don't want to go over, so we can't use 1/4 of an inch. We can use 1/8 of an inch end mill to do it, okay? Now, we don't want to get too close to it. So what if we were doing a 1/4 inch hole instead of a 0.191 hole? You typically don't want to do that either because you would use a drill for that. And you can actually use a drill bit in an end mill. I don't want to get into that right now. There are some caveats to that and how you use it and so on. Typically, an end mill is something that you want it to go down and then go around a hole. Okay, so you don't want it to go just straight into a hole. It won't finish that hole as well. Okay, and we want to be very precise. So we want something smaller than our actual hole. So if it was a 1/4 inch hole we were wanting to do, we might pick the 1/8 inch end mill to do that hole. Okay, I'm going to hit select here. All right, so now you'll notice it put the path on here. So it comes down and it does this kind of wiggle all the way down here, right? And it'll go through the hole doing that. Oopsie. Let me just rotate a little bit. There you go. And you can see it going all the way down through there. Okay. Now we can change a bunch of the parameters around this, and I'm going to show you some of that as we go. So selected the tool, and it happened to be that I clicked on the hole earlier. So over here, oh, by the way, on this one, you don't have to worry about the rest of these. The rest of these are already put in because they are pulled from the tool library. That's why that tool library is so important. And that's why being part of the Crimson Robotics team account is important, because it gives you access to all of these tools, okay, or all of these end mills, okay? So we have the 1/8 inch flat end mill. All of these get filled in for us. Some of them we have wood as a preset for as well. In this case, we just have aluminum for the 1/8 inch. Okay, so we're then going to go to geometry. This is where you actually select what we're going to mill out. So we can select the next hole and the next hole. Well, you know what? I'm not going to select anything for now. I'm going to select one hole, and then we're going to select all the same diameter. Okay, which it's intelligent enough to go and pick all of them. The problem is it also picked all the holes on the opposite side of our tubing as well, because they're all the same size. Well, we can't do that because it's not flipped over to the other side. So unfortunately, we can't use select same diameter right here. However, only same hole depth, yeah, only same Z top height. This is what's then critical. We can't just select this top one. We have to also select this only Z top height at the same time. There we go. Expand that a little bit so you can read it. So that means that the same Z top height or the same surface on the top is, it has to be on the same surface and it has to be the same diameter. And now we've got just the holes that we want to mill out, okay? And then we can change the order and do things like that. I'm not gonna go through all the options, by the way, on all of these, or we're gonna be all night long doing that, but you don't really have to worry about the rest of these. These just help you choose the geometry. If that helps you choose the geometry, that's great, go ahead and use them. But if not, just select the areas that you wanna mill out and go from there. Okay, then we get into our heights. This is important too. So, this is the height that our end mill will come down. So let me get to the front here. All right. So our clearance height, our retract height, and our top height. So we can see where our top height is and our bottom height. Hold on here. Come on. Bottom height. Okay, our bottom height, we actually want it to go down a little bit further than the bottom of the hole, okay? So we actually want it to go down, say, 20 thousandths of an inch, so negative 0.020, 20 thousandths. And notice when I change it to 20 thousandths, see what happened here? It actually shows it going down further below the hole. Okay, this just clears out our hole a little bit. You might even be fine with 10 thousandths. I'm playing it safe with 20 thousandths right now. The reason why you wouldn't want to go down further than that is maybe you don't want to cut into the wasteboard very much. In this case, we're just cutting into air, so it's no big deal. But if you were actually doing this over on our wasteboard, maybe just 10 thousandths of an inch is enough, and then we won't be messing up our wasteboard quite as much. Okay, that's one reason why you might not want to go down as far. Our top height should be fine. Our stock top, this just means that it'll retract 0.2 of an inch above our stock top to move to the next. And our clearance height is, and by the way, you can just roll over these. The clearance height offset is applied and is relative to the clearance height selection in the above drop down. Okay, I get that. Boy, they don't define that one very well. Retract height offset is applied. Yeah, that's the same thing. So it retracts above 0.2 of an inch, and it's 0.4 of an inch then above the retract height for the clearance height. This is when it's actually moving over to it as the clearance height, I believe. I believe the retract height is between holes as it retracts from one to the next. Perfect. All right, so we can see where our retractions are. We can see we're coming down just a little bit below the hole. And so that's great. That's perfect. Okay. Now we go to our passes. We can actually leave a little bit of stock if we want to. There's a lot. Now, why would we leave stock to leave? Typically what you do in these operations is a roughing pass. So you go in and you make your hole, and then you come back later and you do a fine grain pass at the end. This gives you a much more precise path or a much more precise movement afterwards, okay? Doing it twice will make it more accurate than if you just do it once and go in there with a roughing pass. You can use the same tool at times. So you can use the same end mill if you want to do a second pass. So in this particular case, you know, if we're doing rivets, we may say, you know what, we've already got these measured reasonably enough, and we know that it's going to be decent. We won't leave any stock to leave at this point. I'll do this in another operation, and I'll show you how we go about it in a second with the bearing holes, because bearing holes are very important to have very precise. The rivet holes, maybe we're close to that, but we don't have to have it as tight, okay? In this case, we'll pretend that's the case and go from there. our tolerances and the rest of these things, I encourage you to explore them, but we're not going to change any of those for this particular time. Okay. And again, read the pop-ups. They are incredibly detailed. They've got some great information in them. Okay. Linking, we also don't have to worry about at this point in time either. I don't do anything with this tab at this point. We have some of these predefined. Okay. We click OK, and we have our boring operation completed now. And we're good. Okay, so now we have our holes on this side.